Welcome to aminacademy.com. In electrical engineering regarding electric field, let us do some solving problems. Here, look at this example. What is the magnitude and direction of electric field due to point charge of 20 microcoulomb at a distance of 1 meter away from it? Here, the given things. Q equal to 20 microcoulomb, distance is 1 meter. Now, we know that electrical field E equal K into Q over R square. We know the K value 9 into approximate 10 power 9 into Q equal to 20 micro 10 power minus 6 over the distance is 1 meter, okay, which gives 1.8 into 10 power 5 Newton per coulomb. Magnitude we found the Newton per coulomb, 1.8 into 4.5 Newton per coulomb electric field. Then find the direction. Look at here. Here we know that exact value of K equal to 8.99 into 10 power 9 Newton meter square per second coulomb square. The sign of charge determines the direction of the electric field. In this case, since the charge is positive, because Q is positive, therefore here this is a plus 20 microcoulomb. Then this is electric field is this side because it's a positive. Then next question, an electron is released. Next question, an electron is released from rest in a uniform electric field of a magnitude equal 100 Newton per coulomb and gains its speed. Find the magnitude of the force applied to it. Second one, after traveling a distance of 11 meter, how fast does it reach? Look at here first one, the given things, we know that electronic charge equal 1.6 into 10 power minus 19 coulomb, and electronic mass, one electron mass is 9.1 into 10 power minus 31 kg. Using these values, you can find the electric field and electric force are released related by the formula. You know that F equal Q into E, because Q equal to F over V, therefore F equal to Q into V, that is equal Q equal to 100 Newton per coulomb, 100 Newton per coulomb into E equal 1.6 into 10 power minus 19, which is equal 100 into 1.6 into 10 power minus 19 is 1.6 into 10 power minus 17 Newton. That much force required. The second part, after traveling a distance of 11 meter, how fast does it reach? That means this part is related to kinematics, that is a problem of kinematics. From rest means the initial velocity of the electron is V0 is 0. By combining Newton's second law F equal to ma and the kinematic equation V square minus V0 square equal to 2ax, then v square minus v initial square equal to a, that x distance. We can determine the speed of the electron after it has traveled 1 meter through the electric field. This is not 11, we can keep it this 1 meter. Then we'll use it now. V square equal to V0 plus 2ax. That V0 equal to 2 f over m x plus V0 square. That is 2ax is f over m is acceleration and 2 is here x V0 square. Now we'll apply the values. 2 into force is 1.6 into 10 power minus 19 Newton. Mass of an electron is 9.1 into 10 power minus 31 into 1 plus x distance is 1 meter. Then it is 0 square. So we have 0.35 into 10 power 14. This is v square. Then v equal square root of 0.35 into 10 power 14, which is equal 6.6 into 10 power 6 meter per second. After 1 meter travel, it acquires a velocity of 6.6 into 10 power 6 meter per second. Next question. 3-point charges located in an equilateral triangle. Here, 3-point charges are located at the corners of an equilateral triangle as depicted in figure. Find the electric field at a point midway between the two charges placed on x-axis. Here is the 3 charges located like. Now this is 4 microcoulomb. This is 10 microcoulomb. This is minus 6 microcoulomb. All are 60 degrees because equilateral triangle. Then 0.5 meter. Everywhere 0.5 meter. 0.5 meter. Here we have to find between this point is midpoint you have to find. An equilateral triangle is a triangle that you know that all sides are equal and angles are equal. In this question you are asked to find the net electric field midway of x-axis. You have to find the midway of x-axis. Now C equal a square minus b square, because according to Pythagoras theorem it can find the distance denoted C, the point C here. Point that one is 0.5 squared minus 0.25 square, which is equal 0.43 meter. An electric field due to the charge 10 microcoulomb at a point P. Now look at here, E10 electric field at 10 microcoulomb charges equal K into Q over R squared equal to 9 into 10 power 9 into Q is 10 into 10 power minus 6 because of microcoulomb over the distance. Midway distance is 0.25 the square, which gives 1.44 into 10 power of 6 Newton per meter. Then, since the charge is positive, that is 10 microcoulomb, the electric field is directed to the right. Similarly, for a minus 6 microcoulomb, that is e power minus 6, E of minus 6 coulomb is same K into Q over R squared, that is 9 into 10 power 9, 10 power 9 of 6 into 10 power minus 6, that is Q over 0.25 the square gives 0.86 Newton per meter. Here the charge is negative, so that the electric field at point P is directed to the right. Finally, for the charge here 6 is negative, then for 4 microcoulombs, E for 4 microcoulomb is K over K into Q R square is 9 into 10 power 9, Q is 4 into 10 power minus 6 over 0.43 the square. That means we found the distance C here, which is equal 0.9 into 0.19. 0.19 into 10 power 6 Newton per meter. Since the charge is positive, the electric field at point P is directed away from it. Therefore, we'll draw the things now one more time. Look at here. This is 4 microcoulomb, 10 microcoulomb, minus 6 microcoulomb. Drop here perpendicular. That is E4. This is E power E of minus 6 and E of 10. So this is y direction, this x direction. So therefore, along the positive x direction, there are two forces that add together and make x components, and the net electric field of P equal. Therefore, you can find E net to x axis equals 0.86 plus 1.44 into 10 power 6 which is equal to 2.30 into 10 power 6 in I direction, Newton per meter. Then E net in Y direction gives minus 19 into 10 power 6 J direction, Newton per meter. Therefore, E net equal to square root of E x square plus E y dash square, which is equal, Ex is 2.30 plus minus 9 the square. Here, squaring and adding make the square root, we get 2.31 Newton meter. We got a E net, that is electric field at net depth, because in xy direction we got the resultant. We have done. Please subscribe our YouTube channel.